to MIPI DevCon 2020. Thanks for joining. We're glad to have you with us today. Feel free to engage with the presenters and attendees by using the engagement tools at the footer of your screen. Click Q&A to engage with presenters and group chat to communicate with the attendees. You can simply minimize or maximize each of these icons with one click. To see the agenda, sessions, and demos, click on the Call to Action icon. Enjoy the conference.
Good morning, good afternoon, or good evening, depending on where you guys are logging in from. We're excited to have you join us. Hi, I'm Kevin from San. I am the current chair of the Marketing Steering Group. I have the distinct pleasure of hosting the final session of the day with an exciting fireside chat on MAS, MIPI's Automotive SerDes solution. And really what we're going to talk about is how important is a standard SerDes really to the automotive market. Okay. I hope you've enjoyed your first day of our first virtual MIPI DevCon. We were honored to start off our day with our keynote from Andreas Locke from Bosch, talking about trends in automotive communications. And we're glad to have him on our auto fireside chat as well for a more interactive discussion and the day off. Okay. If you didn't catch his keynote earlier today, I encourage you to go back and take a look at it. Andreas has a PhD in solid-state physics. He's held several positions in sensor development, ECU development, and system engineering. So clearly, he has a good understanding of the automotive system. Our second panelist today comes from Synopsys. He has over 21 years in the industry. He's the product marketing director responsible for automotive, consumer, and mobile product lines. So driving an IP product line, he has a unique view of the automotive market and a broad understanding of what developers are looking for today and into the future as well. And finally, we round things off with Rick, who is the Senior Director of Technology at Qualcomm. He is clearly an industry veteran and established the Advanced Connectivity Technology Office in Qualcomm. He's authored numerous publications and holds a variety of patents in device architecture and operations. So clearly, he's going to give us a critical perspective of what automotive semiconductor companies are looking for and the direction they're going towards in this automotive industry. So panelists, I welcome you and I thank you for joining us. Truly an honor to have you with us today. So to start things out, as we have shared, I think we all know that the automotive market has been one of the most active investment areas for semiconductors in recent years. With the growth of electric vehicles, the expansion of assisted driving, and the goal toward autonomous driving, we're seeing significant growth in the major electronic components in the car. For myself, I don't like driving, so I can't wait till the day we actually get to this true autonomous driving. Okay, but in getting there, there are still significant opportunities, but significant challenges. So today in our fireside chat, we're going to explore really about the semiconductor market and address some of these opportunities and challenges for automotive, specifically around these because it's become a very big issue in recent years. Not only that, we want to touch a little bit about things that impact the automotive market as well, like safety and security. So with that said, and to give our panelists as much time to discuss this, let's just jump into it. And the first question that I will give to the panelists to discuss is really about what I talked about. For the automotive market, what do you see going on in terms of opportunities and some of the challenges, specifically around the need for SerDes in this market? And maybe let me start off with Andreas, maybe you can give us your perspective, especially when you talked about communications in the car in a keynote already.
Okay, yeah, so as I mentioned in my keynote speech, the automotive market is a big transition, electrification, connectivity, and automated driving. So, and this has a very, very large impact on the e-architecture in whole, but also on the communication network specifically. And as we see, so bandwidth will increase dramatically in the next years because we have a lot more sensors which have to deliver high amounts of data. So I think this is a very, very good both opportunities for all semiconductor providers which go into that area of the market.
Okay. And Hezi, from an IP perspective, what are you seeing in terms of what customers are asking for in terms of communications and SerDes in the car?
Yeah, we're seeing automotive architecture evolving to address new challenges. Mainly integrated controllers per domain. There are a couple of domains in the car that are being addressed in a different way right now through the electrification, as Andreas was saying. The gateway, the infotainment, V2X, the comfort, the ADAS, and powertrain. And for all these kind of domains, there are some common requirements that go along for each one of them. Their functional safety, security, reliability, software development, AI or deep learning that is applicable to some of those domains, and low power. So we definitely see the fact that the automotive market is moving towards the integrated controllers per domain, as I said, but also sensor fusion is coming along, as well as connectivity and upgradability, which is becoming a requirement for the next cars.
So clearly from both your statements, we see that there's going to be a lot of opportunities there. So Rick, for you, as a semiconductor guy in building chips for this, where do you see the challenges in building these chips, or what are you looking for when you guys are building the next generation of automotive chips?
Well, one of the key things about a semiconductor company, we all like standards. Every new interface that needs to go into silicon is a big deal. So the mere fact that we're now approaching the first SerDes standard in automotive for long reach camera and display connectivity, it's really important. So the fact that the MIPI A-PHY is the first standard will make it a lot easier, to get the ecosystem to rally around one solution. Why is one solution always preferred in terms of technology? It's because it goes into a broad range of chips, a broad range of sensors, and of course a broad range of displays. So having a single standard is something that we look forward to as we kind of grow the A-PHY ecosystem.
Okay, and that's a great point. And I didn't bring up, but the viewers should be seeing that we do have a standard diagram there as a representation of what a SerDes can do. Either Rick or Hezi, can you talk a little bit about your understanding of what SerDes is and what are the requirements within an automotive vehicle today?
Maybe I can start, Hezi, and then you can pick up. Does that work?
Sure. Go ahead. Yeah.
Yeah. So yeah. Thanks, Hezi. So in the diagram, we see just a very high level kind of picture regarding what SerDes is. In effect, it's the red lines. It's a 10 to 15 meter cable that connects up to 12 or more cameras to a central processor, the ECU. The fact that it is one standard, whereas today's ecosystem there are a number of proprietary SerDes out there. So the fact that there's one standard that will connect the multitude of cameras in a car and across the different tiers of cars is very important. On the other side, we have the graphics processor feeding the number of displays in the car. So the one standard is a big deal. MIPI is the first standard that would address this in a secure fashion. And the picture that's really shown is if you like, the simplest pictorial of the architecture. Of course, there are a number of cameras and a number of displays in the cars. So that's kind of the big picture in terms of kind of the architecture. The one thing that's shown in the bottom is in orange are the various safety and security features associated with the A-PHY solution, which I think we'll be able to talk about in a little bit.
And so, Hezi, to follow up with Rick is, with the SerDes, what are some of the challenges in automotive with SerDes that are being used today or needs to happen in the future?
Yeah, so today the dominant solution that is available in the market for long are proprietary interfaces. And the challenge is that for each automaker, they need to find the right solution for them to qualify that for different distances and for different use cases. It also makes them captive to a certain proprietary solution. It's very difficult to upgrade and to move on from one technology to the next. Now, with the ever-enhancing requirements for bandwidth, at least on the sensor side and on the display side, it's very difficult right now to upgrade that all the time and to get kind of solution that is available and scalable for the future. So A-PHY, in terms of the challenges and the advantages, it's really supporting that use case, the use case of getting the sensor communication and asymmetrical link from one side to the other, as well as sending the display information from the ECU to the display itself. The fact that it can reuse the MIPI mature CSI2 and DSI protocols that are used extensively in mobile phones and billions of units for a couple of years. And this is really something that is embedded also the A-PHY with its mass solution that we're going to talk about later. I hope will actually have a consolidated solution, end-to-end a solution that really provides you the safety and assurance that you need for that kind of automotive application.
Okay, and finally, before we transition to a slightly different topic, is Andreas, you talked about automotive communications. Can you share a little bit about how the SerDes is kind of changing communications, and some of the more traditional ones are still going to be there, but we're seeing a transition in how the communications in the car is happening?
Yeah, so as I mentioned, so the bandwidth I need for the high bandwidth will go up in the next years because we will see much more functionality and also communication to the back end. So that's one thing. And with the advent of automated driving, you have all these sensors which provide a high amount of data. So, and I think the big ECUs or weaker computers in the car will be connected via Ethernet, but I think SerDes fits very well into the area where the sensors and display needs to be connected. And I think the asymmetric communication is a clear benefit of this SerDes technology in this case, because I think you end up with a more cost-effective solution, which all automakers look for.
Okay. So kind of in summary, from what I hear from what the three of you guys have said is the critical things and the important things looking for is standardization, the high performance and the bandwidth, the long distance and the asymmetry, and the ability to reuse and leverage existing technologies like CSI and DSI seamlessly in the car. Now, something that Rick brought up that I'd like to spend a little bit of time on is security and functional safety. And that's something you brought up that I think is becoming more and more critical in the car. Can you expand upon that, Rick, and what your thoughts are about how the automotive market is changing in terms of security and functional safety?
Sure. So the MIPI solution is fundamentally founded on functional safety as in the ISO 26262 spec. So that basic framework is being honored in the MIPI safety and security solution. The way that the solution has been looked at by MIPI is that we need to offer three types of protection, if you like, to the data. One, of course, is functional safety. The other is general security. I'll talk about that in a minute. And the other is to support HDCP for premium content protection. essentially the Hollywood type movies. So with those three elements, functional safety, security, and HDCP for displays, that kind of sets the framework for the MIPI solution. Just to speak a little bit about security per se, essentially there's two or three main things in play. One is when you plug a peripheral like a camera into your system, you need to be able to authenticate that the camera comes from a properly certified source within the MIPI ecosystem. Similarly for the display, very similar to how when you plug in a battery or a printer cartridge, it essentially verifies that it's certified within that ecosystem. So essentially we refer to that as authentication. And then there's encryption and other types of integrity protection to make sure that the data from the sensor to the ECU and similarly to the display hasn't been tampered with. So with these three kind of vectors of security, the MIPI solution, which is now going to be a standard with these features, will make a big difference in terms of how the ecosystem can safely use these peripherals, cameras and displays from really quite a large ecosystem.
Okay, and my understanding is what you shared about this being as part of the standards is something different that MIPI has done versus other implementations in terms of designing into the spec, and whereas before it's really been up to developers to decide how they do some of the security and the functional safety. Can you talk a little bit to that, Hezi?
So what MIPI did is really to not just deploy the physical layer, the link layer, and that would connect to the protocol layer, the CSI and DSI, etc. What MIPI has done, they took really a solution which is more comprehensive. And so for the link layer that really connects to the SerDes, that tunnels the display and the camera and additional data info, what we have done is really providing a connectivity, easy to connect. So adaptation layer for each protocol, and for each protocol itself, also there is a safety kind of protocol that is connected to that as well. So the ISO 26262 and all the safety mechanism are considered already within the protocol itself. So you can really have a safety, a cohesive safety strategy using an AFI kind of implementation end-to-end, or what we call it from glass to glass.
Okay. Which leads to the next item. You had mentioned MAS, MIPI's Automotive SerDes solutions. You've mentioned end-to-end. You've mentioned glass to glass. How important is that for automotive to have an end-to-end solution versus what is being done today? Hezi, if you want to continue with that, or even Andreas, would you have any comments on having end-to-end solutions and how that may help the industry?
I can start with saying the vision, right? The vision of what we see in the market. So as we said today, today the market itself is serviced by proprietary interfaces. This makes the life of car makers very, very difficult, very not easy to upgrade, to scale, and to support all the different use cases and the higher bandwidth that we see. So we believe that with the standardization and for the long reach asymmetric link, there will be kind of a transition of the market from proprietary interfaces to more standardized one, starting with application that's really providing more of a bridge concept. But then later on, the ability to provide end-to-end solution will really mean that sensors themselves and devices themselves, like the display themselves, could implement AFI technology with a link layer, with adaptation layer, and with a DSI, CSI, EDP, etc., connected directly in the SoC or in the IC itself, that would connect end-to-end without the need for any bridges. So the benefit for the user at the end of the day will be user meaning as the users of the car, but also the car makers and the OEMs, is that this is going to be an optimized architecture that is available and ready to scale. Reduce the wiring, reducing the cost, reducing the weight. You have all this flexibility for supporting all these kind of protocols, to upgrade it to the latest protocols and latest speeds. With underlying technology advancements of API that provide you EMC immunity, that provides you really a bulletproof solution that is really providing you a future-proof solution as well for the car.
And Andreas, what are your thoughts about mass just in general? As Bosch, I would think that you guys deal with a lot of different specifications, a lot of different interfaces when you connect things. Having a mass solution, is that of value to you in your development cycle?
Yes, of course. I think it will bring down the development effort and also will add to improved time to market, because you can really rely on this end-to-end solution. And this helps, I think, the tier ones, but also the OEMs to focus more on the application than of bringing different technologies together.
And Rick, how about your perspective on mass, and how does this help you as a semiconductor developer, having an end-to-end solution like mass?
Right. Well, right now, the solutions between a camera and the ECU or the application processor, if you like, is completely different than the solution from the same chip in many cases to the display. So if you like, the left-hand side of this picture is very different today from the right-hand side. So the camera, even though the protocols are different, the architectures that need to connect cameras to the ECU and the ECU to the display are very different. So having one solution that's consistent across cameras and displays, as well as other sensors, simply makes it a lot easier from the semiconductor perspective. There's one interface that will eventually be used for all cameras and all displays. Whereas today, when integrating into an automotive environment, they're very different. So that's the big unification that we expect with one solution that spans all the way from camera, the glass, to the display, which is the other glass. So one kind of unifying architecture makes a big deal when integrating into a chip, as well as Andreas said, integrating into the car at large.
Okay. So what I'm hearing is there's still a lot from a challenge. There's still a lot of fragmentation in the market in terms of how things are being connected, and having a standard connection would be beneficial. Everything from the chip makers to the tier ones to the OEMs to allow us to innovate in different ways and focus in on different things if we could standardize things.
Yeah, I wanted to add to that. I think, what's important to say is that API is aimed to solve the asymmetric link in the car, and it does not aim to replace Ethernet entirely in the car. Ethernet has its way, and it is the de facto networking standard. So when we're looking at domain ECUs like camera domains and maybe the display domains, if we can call it like that, we're talking about connectivity from LiDAR, radar, cameras, multiple cameras to the domain ECU that can be done more efficiently and standardizing it using an API kind of a solution that really unifies the whole subsystem. But we're talking about connectivity between ECUs and with the central communication node using Ethernet. So I think it's really the message is more coexistence with Ethernet. Is not a need here to displace Ethernet when we're talking about the networking session.
That's great. So basically, you talk about having a standard SerDes solution that complements the connectivity solution that's being driven in the car today.
Yep, that's right.
Okay.
No.
Okay. Hey, I appreciate your time. I know the time was very short. We could go on for a long time. But what I wanted to do is to provide everyone, just a chance at some closing comments due to time. So, if there's any additional things points that you'd like to make or comment on, this is your opportunity. What we'll do is we'll start with Andreas to give you a minute or two to just make some final comments before we close out our session.
Okay. As just mentioned, I think we see a coexistence of different technologies, and I think the transition, the introduction of new technologies will take some time because the automotive industry did a lot of investments in the last year, and I think they also tend to preserve at least partly their investment. But on the other hand, I think they face new challenges. I think in this, the market will decide so how fast these new technologies come into vehicles.
Okay, thank you, Andreas. Hezi, we'll give you time to summarize.
Yeah, I think what we talked about is really trends towards so moving from distributed systems to more centralized systems in the car, higher bandwidth to support ADAS, infotainment, kind of domains, and the need to standardize and to support safety and security concepts. Those are becoming really linked and very important to the industry going forward. Supporting and really taking care of systematic faults, random faults, either permanent or transient, are also very critical to make sure whatever you are implementing does not really affect you while you drive the car later on with your user. So I believe this kind of standardization effort using API and the stacks that are the link layer and adaptation layer and the different protocols really provides a comprehensive and systematic approach to solve that problem. And that will effectively, the vision is that like in the mobile industry where MIPI started and standardized the camera interface first with CSI and DeFi and made the camera connect to the application processor in a standard way, eliminated a lot of hurdles and a lot of problems that were there having different files implemented by different application processors, and remove that from the equation. So everybody can really focus on the innovation itself, not the link between those SoCs, but actually the innovation within the SoC or within the IC itself. How can you make the technology better and focus on the real value for the end user?
Thanks, Hezi. I think you make great points. This is innovative technology that really kind of standardizes things, that drives the complementary technology. It provides the asymmetry that you were talking about that the automotive market needs. And Rick, we'll end with your final comments.
So I think one of the big takeaways here is that MIPI, of course, started with smartphones, and the CSI2 and the DSI2. CSI, DSI, as well as the use of DisplayPort standards from Visa. Essentially, what MIPI is trying to do is to leverage those protocols as much as possible in order to kind of leverage the history of about 20 years of use within smartphones. So in effect, it's leverage and extend. Just like we, don't really want to spend a lot of time innovating on protocols. We want to focus here on the physical layer. So MIPI's approach is leverage and reuse the protocols while building a really capable physical layer, and that in effect extends very nicely MIPI's work in smartphones to automotive.
Thanks, Rick. I think again a great point is leveraging technology. It's not trying to reinvent the wheel, but making sure that the wheel works the way it should be for the particular application. So we're leveraging the existing CSI and DSI and standardizing the physical layer that is needed to go into the automobile. Okay. Hey, I just would like to just thank the panelists for your time. We really appreciate your insights and your comments on what's going on in the automotive market. I encourage those who are watching right now, as I mentioned, MIPI has released the version 1.0 of the API this week. So if you're interested and you're working on things with automotive, please take a look at the specifications. And if you have any questions, get involved with MIPI and come join us. We have a variety of automotive working groups driving things. So if this is an area of importance to you and your company, come and join us. Again, thank you very much, panelists, and you guys have a great rest of your morning, afternoon, or evening, wherever you are. Goodbye.